The Sun is a star that formed 4.6 billion years ago in our Milky Way galaxy. It is the largest and most massive object in our solar system, whose energy enables life on our planet. What happened at the time of its birth? Was its formation similar to most stars in our galaxy, or did it form in special circumstances? These are some of the questions we all are wondering about. Friends, in this video, I will try to explain the formation of our Sun. First, let me tell you the basics we know about our Sun. The Sun is a star, a hot ball of glowing gases at the heart of our solar system. Its influence extends far beyond the orbits of distant Neptune and Pluto. Earth is the third planet from the Sun at a distance of about 93 million miles. The Sun holds 99.8% of the solar system's mass. Its average diameter is 864,000 miles, which is roughly 109 times the diameter of the Earth. The surface temperature of the Sun is about 10,000 degrees Fahrenheit, while temperatures in the core reach more than 27 million Fahrenheit, which is mainly driven by nuclear reactions. Without the Sun's intense energy and heat, there would be no life on Earth. The Sun is terrifying and gorgeous, and it's also the best physics laboratory in our solar system. Around 4.6 billion years ago, our Sun and all other objects that orbit around it were born from an enormous cloud of interstellar gas and dust. The so-called nebular hypothesis, the idea that our solar system arose from a collapsing cloud of gas and dust, has a long history. In 1755, the German thinker Immanuel Kant suggested that both the Sun and planets formed alongside each other from a more extensive cloud collapsing under its own gravity. Under the influence of gravity, the cloud began to contract and rotate. The contraction rate near the center was greatest, and gradually a dense central core formed. As the rotation rate increased, due to conservation of angular momentum, the outer parts began to flatten. Some of the dust and vapor near the outer edge of this disk formed smaller condensations, each spinning around its own center in the same direction as the parent cloud. These were destined to become Earth and the other planets of our solar system. The contracting cloud began to heat up, to glow, and to exert pressure that counteracted the gravitational infall. This glowing core was now a protostar, surrounded by dust and vapor. The Sun stayed in this cocoon-like state for about 10 million years until its true stellar birth. While the protostar slowly radiated its energy away, the pressure in the hot core decreased, allowing the core to continue its collapse. The temperature increased until it became so hot that the first nuclear reactions were ignited. With the start of nuclear reactions in its core, the Sun began its life as a true star. The Sun has remained in this stable state for the last 4.6 billion years. But what of its future? This is a big question. Friends, in the next video, I will discuss what is the future of our Sun.